Today's item is so big and heavy, I've had to crack out another bench here in the shed just to be able to show it off. This is the EPEver STI, interesting choice, 500 pure sine wave inverter, and obviously this is an inverter, and it takes between 21 and 32 volts here on this left hand side, and on the right hand side of this unit, which is definitely the heavier side of this unit, it's got a 230 volt output, a standard sort of European output there, with a multi-plug adapter on there, so you can plug various different nations plugs into there. An RS485 port on an RJ45 connector, a couple of switches to turn it on and off, and have it in normal or saving mode, 3 LEDs, one to say that the DC input is good, one to say that the load output is good, and a fault light as well. Right, before I plug this in and give it a go, I've taken the 4 screws out of the top here, and hopefully that will, yes, release the lid on the STI, yep, 500. And wow, yeah, so there's the transformer, and that's bolted down to the bottom of the case. There's a large metal plate holding it on there. This is just a little daughter board here on the right hand side where the RS485 communication is, which comes down to this control module here, which is marked STI 24 volts. So that's pretty much what you'd imagine. I guess the input here on the DC input goes through to these bus bars here. There's 2 of them, positive and negative, and the positive, yes, has 3 25 amp fuses on it, which are presumably in parallel, giving 75 amps of fuse protection, last resort protection, I guess. There's what look like 4 MOSFETs on the case, bolted onto the side of the case there for thermal cooling at the bottom, and another 4 at the top. And yeah, well, that's pretty much what you'd expect. It seems to be reasonably well made. The size of the cable is pretty good by the looks of it for a 500 watt inverter. The caps are rated at 35 volts, so that's above the maximum input, so that's not too bad. Yeah, that's yeah, pretty good. I think well, what we'd expect, and of a reasonable quality. A quick look at the manual shows the overview that I've just shown on the outside of the case. It shows a couple of different units. You can get versions, the Australian, the European, but mine comes with that plug, which can be pretty much any country whatsoever. The LED status lights are explained in this section here, and it's also got a buzzer in case of overload or that sort of thing. There is short circuit protection and overload protection already built in, and crucially for me, input low voltage protection. On the 24 volt system here, at 21 volts it will switch off, and that's perfect for my 7S 20p lithium ion pack, because 21 volts divided by those 7 packs in series, well, that's 3 volts, and that's definitely as low as I want to take my recycled lithium ion 18650s. There's also over voltage protection, which hopefully should never kick in, because I've got various other things preventing that from happening. Fault protection, over temperature protection, and reverse polarity protection as well, all built into this particular inverter. And finally here, the savings mode. Well, if the output is less than 20 VA, then it will go into a power saving mode until the requirements are significantly higher than that, I guess, and then it kicks into its full blown mode. So that might be useful. We'll have to wait and see. In the technical specifications, the 24 volt version, I've got the 230 volt output version, mentions those lower and upper voltage limits there. No load consumption less than 5 watts apparently, pure sine wave, 230 volts AC plus or minus 3%. It can do continuously 200 VA, which is the 500 watt rating, I believe, but you can burst for short periods of time above that. So it will do 300 VA for 10 seconds, 400 VA for 1.5 seconds, and it will actually burst all the way up to 1500 watts or thereabouts if you require it for a very short period. The efficiency is rated somewhere between 85 and 89%. So, well, that seems reasonable. So the EPEver STI500 is now on the wall of the shed, immediately below the 7S lithium ion pack. Now I just need to wire it up. And for that I'm going to use the 16mm squared welding cable that I've got left over from another job. I've already crimped some ends on it some time ago, marked one positive, marked one negative, and they'll connect to the end of the string without any bother whatsoever, and they should be well capable of carrying the current required by the STI500. And for safety I have a DC breaker here, a Thomson branded 125 volt DC breaker, 32 amps, and that should be suitable for the sort of current that I'm looking to pull. Now this is a polarized breaker. The top part of it, the top connector I should say, is the most positive point, so the positive of the 7S pack there will need to connect through to the top of this breaker, which will sit on that DIN rail, and the inverter will connect to the bottom. So yeah, if you wire these up the wrong way, they may not work in quite the same manner. So I've wired up those cables now to the inverter, but they're not actually connected through to the battery bank here via that DC breaker as yet, so I'll turn off the solar charge controller, disconnect these ends, and connect up the inverter. So I've connected the inverter up to the battery bank here, and well, let's turn it on. And that's powered up now, and while we're here we'll power up the solar charge controller again, and that's showing a voltage on my battery bank of 28.5 volts. I'll also turn on the solar, so when the sun comes out in the morning that will start charging this battery bank. But of course not a lot happens until we turn this switch on here. And there we go, we've got 3 green lights, and presumably green is good to go. Before we move on any further, let's just check the no load current, zero my meter there, 170 milliamps, 160 perhaps to be fair, 160 milliamps there. At what voltage have we got? 28.5 volts, so 160 milliamps at 28.5 volts no load current. And using this meter plugged into this extension, which is then plugged in to the inverter, we can see, if I click through here, 229.7 volts. Well, it claims to be 230 volts, so that's pretty accurate. 50 hertz, excellent, that's what I would expect. Now let's have a look at the sinusoidal wave here on the scope. Let's turn it on, and that seems excellent, doesn't it? That's a perfect sinusoidal wave. Let's put a load on it though, and first of all I'm going to put my soldering iron on, which is about 60 watts, and it's pulling 57.5 watts, and that seems to be absolutely fine, doesn't it? Now I will try the hot air on my soldering iron, and yeah, that's causing a bit of bother, isn't it? Or is it? Is that interference on the scope? No, I think that's actually the inverter, which is flashing away between 2 modes. We're pulling 225 watts at the moment, and yeah, that load does seem to be causing this inverter a bit of an issue. That's a little bit of a disappointment. So after that slight disappointment with the hot air gun, let's try my 500 watt drill. Well, after a little jitter there when I first turned it on, that seemed to hold fairly well, didn't it? So that's my first look at the EPEver STI500 pure sine wave inverter, and the positives are it seems to be very well made, and that no load current seems to be very low, which is really excellent as a standby current. The sinusoidal wave looked excellent until, of course, I put my hot work rework station on it, and then it was struggling a little bit, so I'll have to have a look at that and try some other loads. But yeah, at the 60 watt load for the normal soldering iron, everything was working fine. It also doesn't seem to be interfering with my DIY BMS here on the 7S pack, which is excellent news. And I've now got a way to get some real energy out of these 18650s. So hopefully you've enjoyed this video. If you have, give me a thumbs up, subscribe down below, comment if you can, and I will see you next time. Thanks for watching.